Have you ever stood outside on a clear night? You look up. You see the vast, inky blackness of space, dotted with countless tiny, glittering stars. And then there it is, our moon. Sometimes it's a brilliant, full circle, bathing the landscape in soft, silvery light. Other times, it's a delicate, sliver-thin crescent, a shy smile in the cosmos. But what if it wasn't there? What if you looked up into that same night sky, and all you saw were the stars? No friendly lunar face to greet you, no gentle glow to light your path. Just an endless, deeper darkness, punctuated only by the distant pinpricks of faraway suns. It's a strange thought, isn't it? For millennia, humanity has used the moon as a calendar, a clock, and a source of inspiration. Its predictable phases gave our ancestors a way to track time, to plan for hunts and harvests. Its light provided safety in the darkness, pushing back shadows where predators might lurk. Poets have written odes to its beauty, lovers have sworn devotion under its watchful gaze, and scientists have dreamed of walking on its dusty surface. Without it, the night would be much more daunting, much more absolute, and perhaps much more frightening. Imagine you are an early human, tens of thousands of years ago. Your world is filled with mysteries and dangers. Every single night would be a new moon night. This isn't just poetry or romanticism. The moon's presence would have had very real impact on life, the planet, and our species. So, what's the first big thing you'd notice on a moonless Earth? Well, you'd probably notice it at the beach. Or rather, you'd notice what wasn't happening at the beach. The tides. The regular, predictable rise and fall of the ocean's water level is one of the most powerful and reliable rhythms of our planet. This rhythm is orchestrated almost entirely by the gravitational pull of our moon. As the moon orbits Earth, its gravity tugs on everything, but it has the most obvious effect on the vast bodies of water that cover our world. It pulls the water on the side of Earth nearest to it into a bulge, creating a high tide. And it happens on the far side too. Now you might think the sun, being so massive, would have the biggest say. And it does have an effect. The sun's gravity also creates tides, but because it's so much farther away, its tidal pull is less than half as strong as the moon's. So on our moonless Earth, we would still have tides, but they would be much, much weaker. They'd be solar tides. The great intertidal zones, those incredible ecosystems teeming with life that are exposed at low tide and submerged at high tide, would be vastly smaller, or might not even exist in the same way. Without the strong, regular tides created by the moon, this whole vibrant ecosystem would have had a very different evolutionary path. Let's talk about that braking effect. It's a really big deal. The friction created by those massive tidal bulges dragging against the rotating Earth has been slowly but surely slowing our planet down for billions of years. It's a bit like putting your hand on a spinning top. The friction gradually saps its energy. When the Earth and Moon first formed about 4.5 billion years ago, the Earth was spinning much, much faster than it is today, and the Moon was much, much closer. How much faster? Well, the best estimates from geologists and astronomers suggest that a day on early Earth might have been only about 6 to 8 hours long. Can you imagine that? You'd get up, go to work or school, and a few hours later, the sun would be setting again. Your whole life would be a frantic rush of short days and short nights, over and over again. Over billions of years, this tidal friction has transferred rotational energy from the Earth to the Moon, slowing down our planet's spin and pushing the Moon into a higher, more distant orbit. Our 24-hour day is a direct gift from the Moon. Without the Moon, Earth would never have experienced this significant slowdown. It would have kept spinning at or near its original frantic pace. So, on a moonless Earth today, a day would still likely be somewhere between 8 and 10 hours long. So we have a planet spinning much faster. A day is maybe only 8 hours long. What else does that get us? Well, it gets us wind. Lots and lots of wind. The speed of a planet's rotation has a huge influence on its weather patterns. One of the key factors is something called the Coriolis effect. On our fast-spinning Earth, the Coriolis effect would be dramatically stronger. This supercharged Coriolis effect would mean that winds would be much, much faster. The gentle breezes we know would be a rarity. Instead, The planet would be constantly scoured by powerful, unrelenting winds. Imagine trying to live in a world like that. Building a shelter that could withstand the constant onslaught of super winds would be a monumental challenge. Trees would have to be short, stout, and incredibly strong to avoid being ripped from the ground. Flying creatures, like birds and insects, would have an incredibly difficult time. And it's not just the wind. The rapid spin would affect temperature distribution. The faster spin would mean that heat from the equator would be transported towards the poles more efficiently. But the overall climate system would be so chaotic and energetic that regional weather would be far less predictable. The rapid day-night cycle combined with the violent winds would create a weather system that is constantly in flux. Let's dive deeper into how life itself would have to cope in this fast-spinning, windswept world. The very first life on Earth emerged in the oceans, and even there, the moon's absence would have been felt. The lack of strong lunar tides would mean less mixing of ocean water. The nutrient-rich waters of the deep ocean would be less likely to get churned up to the surface, where photosynthetic life like plankton can use them. On land, the challenges would be immense. For plants, the 8-hour day presents a fundamental problem. Photosynthesis is a complex process, and it takes time. With only about 4 hours of usable sunlight before the sun sets again, plants would be in a constant race against the clock. They would likely have evolved to be incredibly efficient at capturing light, or maybe large, complex plants as we know them just wouldn't be feasible. The world might be dominated by smaller, faster-growing life forms like mosses, lichens, and fungi, which are better suited to a life of short bursts of activity. What about animals? Their circadian rhythms would be completely different, tuned to this frantic 8-hour cycle. Sleep patterns would be shorter and more frequent. Animals that rely on vision would be at a disadvantage, with short periods of light followed by long periods of absolute, moonless darkness. This might favor creatures that evolve to rely on other senses like hearing, smell, or even echolocation. Let us imagine walking through a forest on this moonless Earth. What creatures might we see or more likely hear? With such short periods of daylight, vision would be a less reliable sense for many animals. This would be a paradise for animals that have mastered other senses. Imagine forests filled with creatures that navigate and hunt using echolocation, like bats and dolphins do. The constant high winds would also shape animal anatomy and behavior in extreme ways. Flight, as we know it, would be a perilous affair. Perhaps birds would have evolved to be more like penguins or ostriches, fast runners but entirely flightless. Insects, too, would face challenges. Small, delicate wings would be useless. We might see insects that are heavily armored like beetles, or those that spend almost their entire lives underground or in the water. In the oceans, the story would be different, but no less strange. The lack of strong tides would mean fewer of the rich intertidal zones we see on our Earth. This would have a cascading effect on marine life. Without this gentle, constant stirring, the deeper parts of the ocean could become more stratified and anoxic, meaning they would lack oxygen. This could limit the range and diversity of deep-sea life. And what about us? Or a creature like us? In a world where trees are short, stout, or non-existent due to high winds, would arboreal life even be possible? Perhaps the path to intelligence would have started on the ground, or even underground. Our senses would be different too. Perhaps we would have had much better hearing or sense of smell, and our eyes might have been larger, adapted for the dim light of dawn and dusk. So far, we've talked about the length of the day and the weather. But the moon does something else for us, something incredibly important that we can't see or feel directly. It acts as a giant stabilizer. Think of the Earth as a spinning top. Earth has a wobble too. Its axis is tilted at about 23.5 degrees relative to its orbit around the Sun. This tilt is what gives us our seasons. Our moon, with its significant gravitational pull, acts like a steadying hand on this spinning top. It keeps the Earth's axial tilt, or obliquity, remarkably stable. It doesn't stay perfectly still. It nods back and forth by about 1 degree over a period of 41,000 years. This tiny, slow wobble is predictable and has influenced the ice ages, but it's a very gentle change. Without the moon's stabilizing influence, things would get chaotic. The gravitational pulls from the other planets would tug on the Earth and cause its axial tilt to swing wildly. Computer simulations suggest that without the moon, Earth's tilt could vary from as little as 0 degrees, where there are no seasons at all, to as much as 85 degrees, where the Earth is spinning almost on its side. And these changes wouldn't happen over millions of years. They could happen over much shorter timescales. Imagine a world where, over a few thousand years, the seasons as we know them vanish completely. Then, a few thousand years later, the planet tilts over on its side. For a quarter of the year, the North Pole would point directly at the sun, experiencing constant scorching daylight, while the southern hemisphere would be plunged into a deep frozen, dark winter. When we piece it all together, the picture of a moonless Earth is stark and alien. It's a planet in a hurry, spinning through a short 8-hour day. It's a world battered by relentless hurricane-force winds and ruled by chaotic, unpredictable weather. Its oceans are less vibrant, with weaker tides that don't stir the waters with the same life-giving energy. Its seasons, if they exist at all, are at the mercy of a wild, wobbling axis, capable of swinging from one extreme to another. The next time you find yourself outside on a clear night, take a moment. Look up at the moon. Don't just see it as a pretty light in the sky. See it for what it truly is, a silent partner in the story of our planet. It is the anchor that stabilized our world, preventing it from tumbling chaotically through space. It is the brake that slowed our frantic spin, giving us the long leisurely days that allowed complex life to flourish. It is the conductor of the great oceanic orchestra, its gravitational baton directing the rhythm of the tides that enrich our coastlines. The moon has been our constant companion, our nightlight, our calendar, and our inspiration. It has shaped our biology, our environment, and our culture in ways we are only just beginning to fully understand. Its presence is woven into the very fabric of what it means to be on Earth. From the life cycle of a tiny crab on the shore to the grand, sweeping arcs of human history and science, its influence is everywhere. We are incredibly fortunate to live on a planet with such a large, friendly satellite. It is our silent, shining guardian in the night. It's the partner that makes Earth Earth, and that is a truly great moment in science and in life to appreciate.